Question 10, we've got an application here of the stationary points. The first 3 marks is just using the geometry of the shape to get these expressions. We've got a closed box, that means that there's a top and a bottom to this box. The length of the box, width and height is given. It tells me the total surface area of the box is 108. And the surface area is made up of 6 rectangles. And they're saying the total area of those 6 rectangles is 108. So if I do the area of the bottom, that's 2x times x. So that's 2x squared. So the area of the top is also 2x squared, the top and the bottom exactly the same size. The area of the front, that's a 2x by y, so it's 2x times y, which is 2xy. So the area of the back is exactly the same, that's 2xy. And the area of the side is x times y, which is xy, and the area of the opposite side is also equal to xy. So the total surface area of these 6 areas added together, and it tells me that total is 108. So I know that 2x squared plus 2x squared plus 2xy plus 2xy plus xy plus xy equals 108. So that's 4x squared plus 2, 4, 5, 6xy equals 108. And it's asking me to get the xy on its own. So I've got 6xy equals 108. Take away 4x squared. And then to get xy on its own, I divide by 6. So xy equals 108 divided by 6 minus 4x squared divided by 6. They divided the two terms separately. So I've done the same there. So xy then 6 into 108, 6 and 10 goes once, 4 left over, 6 into 48 goes 18, minus, and 4 6 will cancel to 2/3. So there's the first part. Okay, the second part says, hence show the volume of the box is given by that expression. Well, the volume of the box is length times width times height, which is 2x times x times y. So the volume is 2x times x times y, which is 2x squared y. And then if you look at their expression for the volume, there is no y in that expression, so I'm going to have to substitute for y from this expression I have here. But I can actually, there's an xy here, which is probably easier to substitute. So instead of 2x squared y, if I write that as 2x times xy, then I can substitute in for the xy directly. So that's volume is 2x times xy, which is 18, take away 2/3 of x squared, and expand that. 18 lots of 2x is 36x minus, and then 2x times 2/3, we multiply along the top. 2 lots of 2x is 4x, so 2 lots of 2x is 4x, and then the x times x squared gives me x cubed, so that's 4x cubed over 3 as required. Okay, so there's quite a bit of work there for the 3 marks. And then the last part, and we could have done part B without doing part A, because it asks you for the maximum value of V, and we know that a maximum is a stationary point. occurs at the stationary point. So the condition for a maximum value occurs when, right, it's not dy by dx in this question, because instead of y they used a v, so this is going to occur when dv by dx is equal to 0. So I need to differentiate this expression. So dv by dx, differentiating 36x gives me 36 minus, and the second term that's 4/3, and then x cubed goes to 3x squared. So that's 36 minus, the 3's cancel out, 4x squared. So I need to equate this to 0 to find when the maximum value is. So 36 minus 4x squared equal to 0. That's 36 equals 4x squared. So 36 divided by 4 is x squared. X squared is 9. So there's two values that satisfy x squared equal to 9. So x will be 3 or minus 3. Now then, when I look at the diagram, I mean x is a length, so there's no way that I can use the value of minus 3. Okay, so the maximum is obviously going to come from when x is 3. Okay, x equals minus 3 is not possible for this question, because it's in a real life situation. Okay, not possible since cannot have a negative length. So now I'm working with x equals 3. I need to check that is the maximum and do the check. If I do the second derivative, d2v by dx squared, 36 goes to 0, minus 4x squared goes to minus 8x. And when x is 3, second derivative is equal to minus 24, so it's negative. So that proves I'm getting a maximum when x equals 3. Okay, we want the maximum value of v, so now substitute this value of x equals 3 into my expression for volume. So when x equals 3, the volume is, right, 36 times 3 minus 4/3 of 3 cubed. So 36 times 3 36s are 108, minus, and then I got 3 cubed and I got 3 on the bottom, so that 3 will cancel that to a squared. 3 squared is 9, times 4 is 36, and 108 take away 36 is 72, and the units are in centimetres, so that's 72 cubic centimetres.